Hi, I'm Mr. V. Today's our third day on triangle similarity, which is our unit 3. And today we're going to be talking about other conditions. Previously, we've talked about the angle-angle triangle similarity theorem. Today we're going to use side-side-side and the side-angle-side triangle similarity theorems. And we're also going to explore those, prove them visually, and then we're going to use them in proof along with the angle-angle. So the first thing I want to do, though, is talk about one of the homework problems. And this was the problem from the homework. Some people did not do this and just guessed at it when I asked them how to do it. And that's not appropriate. It's also not good to guess, just to guess. If you are going to guess, like if you guess that this is going to be 3, then you would need to be able to set up the proportion and make sure that it fits. So if this side is 3, if the x value is 3, then that means that this side here would have to be 3. And we notice that this does not work when I fit it in with the large triangle of 6 and 10. 6 and 10 would not be 3 and 3, it would be 6 and 6 or 10 and 10. So 3 does not work. Someone said, well, it's about a half, or it's about 1. If this is 5 and this distance is 1, then I would have 1 is to 5 as 6 is to 10. That doesn't work either. If my large is 6 and 10, and I have 2 angles, I have a right angle here, and I have a common angle at the top, I know that these must be similar by the angle-angle triangle similarity theorem. We know that this distance is x, this is a square, so this distance has to be x. How long is this one? And don't give it to me as a number because I don't know how long it is, but I want to give it as an expression. So this distance, this whole distance is 6, this distance is x. What I want to know is how much is this green. If I mark this in green. And I could mark it like this. My green plus my x value is equal to 6. One student said, well, can you put a variable in there? I said, sure, let's put w. Now, what is w equal to? And don't tell me you don't know, because this is simple algebra. We do the inverse operation to isolate the variable. You subtract x from both sides of the equation here, and you get 6 minus x. So if I substitute 6 minus x here, then I can set up a proportion. X is to 10 as 6 minus x is to 6. When we cross multiply, we get 6x is equal to 60 minus 10x. 16x is equal to 60, or x is equal to, let's see, 4 goes into 61 times 15 over 4. 15 fourths. So it's like 3 and a little bit more. And would that make sense? I think so. Today's lesson on page 2. The next 4 pages contain math talks of marked diagrams. Evaluate each one mentally to see if there's enough information to determine if the pairs are congruent. And if they are, you need to mark them and also tell what information you would use as a theorem. And then write the rule, the shortcut that you would use to say that the triangles are congruent. So I'm going to copy these 2 symbols because I might use them in my proof. On this first one, I'll try to make it larger so that you can see it. I have marked this side is congruent to itself by the reflexive property. And now the 2 triangles are congruent. Why? Because of the side-side angle sometimes theorem, triangle congruence theorem. This angle is 90 or more. This always works. Here I've marked the drawing. Radii of a circle are congruent. So I would say EC is equal to DC because they are radii of a circle. This angle ACE and angle BCD are congruent because they're vertical angles. And the 2 triangles are congruent because of the angle-side angle triangle congruence theorem. In this one, although I have this common side here, there is no shortcut side-side. I do not know that these two triangles are congruent. If I knew that these HI and the FG were parallel, then I could mark the angle here and here congruent, and I could use by side, angle, side. I could say that the two triangles are congruent, but I don't know that. If I knew that side IF and HG were congruent, I could say by the side, triangle congruence theorem, they are congruent. There is not enough information. Here, I've marked the alternate interior angles formed by the transversal crossing the parallel lines. And I've marked this side to itself. So alternate interior angles tells me why these angles are congruent. The reflexive property tells me this side is congruent to itself. By the angle, side, angle, the two triangles are congruent. Here are some solutions. Now, we're going to explore the side triangle similarities theorem. We know that two triangles are similar if the pre-image can be mapped to the image with a finite set of rigid transformations and a dilation. Previously, we've proved this visually for the angle-angle triangle similarity theorem, and we showed that it was enough to map them onto another. We're going to do this visually as well. We could do this with a written proof, but I'm going to show you how it works visually. So I'll go to this URL here. Notice I'm not marking any of the angles, only the sides. Notice that the sides here are proportional. This larger one is a scale factor of 2 times this smaller one. If I went from the larger one to the smaller one, I would be scaling it by a scale factor of 1/2. It gets smaller. So this 5 side matches up with what is marked as 10 over here. This 3 side matches up with what is marked as 6, and the 7 matches up with what is marked as 14. Now, this doesn't exactly work. So this is because this is 6.1. So I need to make this move just a little bit. Oops. So let me see here. I'll try to match this up. Now, if I make this larger so that you can see it, I should be able to map. Wait a minute, I didn't link all the sides together. Let me start over. Go to this right here. I'm going to match this side with the one that says 6 over here. Match this one that's 5 with the one that's 10. So it's twice as much. I'll match the one that's 7 with the one that's marked as 14. Not quite. I don't want to do that just yet. I want to make sure it's 14. So I'm going to move this just a little bit wider if I can. And now I'll make this side match up with this side. It's not going to work exactly because this one's 6.1, but when I go to translate this, I can move this over to a point. I'll rotate this smaller triangle. I'm going to rotate. Looks like I'm rotating the bigger triangle. And I'll rotate it around this point. I'm going to rotate it such that the green lines match up. And when they do, I'm going to dilate. I'll dilate the small one. Dilate using this figure around this point. I'm going to make it very, very large. And then I'll reflect it across this line. So when I reflect it across this line, it matches up, sort of. Not exact, but it's close. So visually, I've proved this. Side. The sides are not congruent when they're similar, but the sides have to be proportional. The angles are congruent. The sides must be proportional. That is, they can all be multiplied by a scale factor to get you from one to the other. And we can do this also with the side angle side. I will leave that for you to do. And then going on, there are some practice problems. I'm going to work through them here. I suggest you do them on your own first and then look at the answers, but here they are. So we're given the short side of a triangle is similar to this one, and it has a length of 20. So the triangle looks like this, and this side is 20. And I could call this x and y and set up a proportion. If I were to do a proportion, I would say x is to 13 as 20 is to 10. When I cross multiply, I get x is equal to 26. And the same thing with the y value. Instead of doing this for the y value, what I'm going to do is notice that my scale factor going in this direction is times 10. And going in this direction, well, I want to go in the one direction. I want to go from the small to the large because I'm looking for the y. So if I multiply 12 times 10 times 2, excuse me, not times 10, it's times 2. 10 times 2 is 20. So 12 times 2 is 24. My answer is 24. Does this work with the x? Yes, it does. 13 times 2 is 26. Here we have sides of a triangle. I could draw the two triangles. Instead, I wanted to point out we're going to go from a scale factor to go from this one to this one. I'm going to go from this one, and it's going to be getting smaller. Where I'm going from is going to be my denominator. So 18, the 12 would go on the top. Are the sides proportional? Is the 10 over 15 the same thing? Is the 8 over 12 the same? When you simplify this, you get to 2/3. 2/3 is my scale factor. If I multiply this first sides by 2/3, that's my common factor here. I mean, it's common thing I'm going to multiply it by, which is my scale factor. 2/3 of 18 is 12. 2/3 of 15 is 10. 2/3 of 12 is 8. So this is my scale factor. Notice I put where I'm going from on the bottom. In this one, we're told that the two triangles are supposed to be similar. So I'm going to ignore this picture and I'm going to redraw it so that it matches up with this one. My short side is 4. This side would go x minus 1, and the other one is 7.5. Now I can set up a proportion any way I go. I notice that going from the large to the small, it's going to be a scale factor of 1/2. Because I go from 8 to 4, I go times 8 times 1/2 is equal to 4. Or it's 8 on the bottom, 4 on the top. Okay? Now, if I take 1/2 of 10, this has to equal to 5. So if x minus 1 is equal to 5, x is equal to 6. I could have done it with a fraction, but why do I want to make more work for myself when it's pretty easy with this? This is a problem similar to what I've done before. I'm not going to work through it for you now. Here we have also a problem. Notice where I'm going from goes on the bottom. So you would set this up as 25 over 10. And that's equal to 40 over 16, which is 50 over 2. My scale factor over 20, my scale factor is 5 over 2. I'm getting larger. Remember our scale factor, if it's between 0 and 1, it gets smaller. If it's equal to 1, it stays the same. That would be congruence. And if my k value is greater than 1, that means that it's getting larger. Here, this is getting larger. Sure enough, from 10 to 25 is getting larger. My scale factor, going from the one to the other, is times 2. So if I'm going this direction, well, it's times 2. I would take the 11 and this. So 11 times 2 is 22, would equal to 5x plus 2. 5x is equal to 20. X is equal to 4. What's wrong with this statement? It looks like 24 is to 18. Is that the same as 20 is to 15? Is that a 4 over 3? This is times 5 times 5. That would be 4 times, wait, 20. I'm sorry, I wrote 25. It should have said 20. 20. These are all 4 to 5, 4 to 3. And the angles are congruent. So what's wrong with this? Well, it should be A, B, C, RPQ. The angles are important. It's important that you get them in the right order. Here we have angles that are alternate interior are congruent. Vertical angles are congruent. I could redraw this small triangle by rotating it. I'll make it look like the other one, 2 ticks and 1 tick. Between the 2 ticks is 3. The one that's closest to the 2 ticks is 2x minus 8. So now I can write my proportion. X plus 3 is to 2x minus 8 as 5 is to 3. Cross multiply. 3 times x plus 3 is equal to 5 times 2x minus 8. When I expand this, I get 3x plus 9 is equal to 10x minus 40. Subtract 3x from both sides, add 40 to both sides. 49 is equal to 7x. X is equal to 7. If I asked for this side length, which might be another question, I would have to substitute it back in. This side length is 10. This side length is 6. Here we have a question. These are congruent. That means that this is congruent to this. Let's see. The R matches up with K. So this matches up with this. I'm going to redraw the second one so it has a like configuration. It only takes a second, and it saves me a lot of trouble of getting things wrong. Between the two is 65. Next to this one is 70. So I have 168 is to 70 as 11x plus 13 is to 65. Now, is there an easier way of doing this? I could plug it into a calculator. I could do 65 times 168 over 70, and then subtract 13 from it is equal to 11x. I'll do that. So 65 times 168 divided by 70. And then I'm going to add to that, or subtract from that 13. And I get my value is 143 is equal to 11x. And so when I divide 143 by 11, I get x is equal to 13. Big numbers, same procedure. Good luck and success.